Hi, good morning, everyone. Um, so first of all, thank you all for being here, and thank you to the organization for having me. We'll do this in English, so I come from Portugal. We could do this in Portuguese, but it would be kind of weird, and my Spanish is not that good. If you speak slowly, I can understand most of the conversation, and I can get by going to restaurants and asking for stuff, and that's about it. So we'll do this in English because it will be less boring. So let me start, if this works. It should work. Oh, okay, cool. So let's start with a couple of disclaimers. So first of all, if you've been following the tech, which I assume you all have, I have the feeling nowadays that service mesh is like Kubernetes was a couple of years ago, and I was discussing this with a few people yesterday here at the conference. So if you went to conferences and saw blog posts and saw some of the literature, Kubernetes a couple of years ago was like the thing that everyone had, but you went to conferences and actually no one had it. So it was awesome in theory, but no one was actually using it because it was too complex. Most of the cloud providers didn't offer a solution, so you have to do everything by yourself. So I feel that service mesh at this point is more or less the same thing for the last 6 to 9 months. So it sounds cool, everyone thinks it's awesome, but you start asking people and no one is actually using it. So in theory it looks good, but it's not at this point. And the second disclaimer is that I'm currently not using it in production, and I'll tell you why. I switched companies at mid last year, and the company that I went to was not at a point that for us to use service mesh yet. So we first had to do a big migration of all of our services. We're now reaching the point where we are actually going to integrate this. So some of the examples that you are going to see are a little bit outdated, especially in terms of Istio, but the idea is that you have an idea of how it works and how we could implement a bunch of this stuff. So let's start talking a little bit about microservices. I think you should all be aware of what microservices are. But basically the idea is that instead of having a big application all working on its own, you split your application into smaller services that talk to each other. Okay. So basically you all are familiar with this type of split. So you have a monolithic architecture where everything works together. You probably have one database, everything goes in there. And then you split it in smaller services. Each can have its own database, can use different programming language, different frameworks, whatever it is. So this looks nice. It's probably what most of people are using nowadays, but this also comes at a cost. But let's first focus on the what can we do with microservices. So it's usually highly maintainable and testable. So you have smaller pieces of components, so you can test it more easily. They are loosely coupled, so this means that you can basically scale one and not scale the other. You can use one framework and one database on one and not on the other. They are independently deployable, so you can deploy one application and see if everything is working, not touching the other ones. They are organized around business capabilities, so you can have a microservice for checkout, you have a microservice for your front end, something, whatever it is. And usually they are owned by a smaller team, or a team can own more than one microservice. So they're basically fast to deliver. They can work in isolation. This needs to be very well implemented so that one service doesn't bring everything down. You can scale them independently, so you can have 2 replicas of one service and 100 replicas of another. You can build some culture around this, and you have more flexibility in terms of programming languages, database, frameworks, whatever it is. So you don't have to have everything on the same bowl. But this comes at a cost, of course. So there's no silver bullet, either with monoliths or microservices. So now that you have services speaking to each other, you need to handle service discovery. So service A needs to speak with service B. You need to know what it is. You need load balancing. Probably you have different number of replicas between service A and service B, and you need to send traffic to each of those replicas. You need to reach all fault tolerance. Like we said before, you don't want one service goes down, everything goes down, so you need to handle that. You will eventually need some form of distributed tracing, so now you can have one request going through dozens of services, so you need to know where the traffic went, how long it take. So even if it's not something like distributed tracing in something like open tracing, you'll need somehow to understand how your traffic flows through your services. You'll need metrics, of course, for different services and correlate them amongst each other, and of course, you will need security. So Service mesh is a network topology, and the basic idea is that you don't have special nodes to handle some, some specific tasks. So the nodes speak to each other, and somehow they organize themselves into making a network. You can have special nodes in terms of where information is stored and where the node itself can get information, but they don't have to. The traffic doesn't have to flow to some specific node for something to be done. And the service mesh builds on top of this idea. So the service mesh aims to be the connective tissue between all of your services and to allow stuff like traffic control, service discovery, load balancing, resilience, open tracing, all that kind of stuff. So that's the basic gist of what a service mesh is. Most of the service mesh implementations are built on top of two main concepts. The first one is very familiar to all of us, which is a service proxy or a proxy on and on itself. Probably most of you are using something like Nginx, Envoy, Traffic, whatever it is. So the idea is that you don't contact a service directly. You send traffic through a proxy, and then proxy will forward traffic down, and it will handle stuff like load balancing, circuit breaking, all that kind of stuff for you. And the other pattern is a sidecar pattern. It's where this concept is where your application lives alongside another application, and they all have the same life cycle. So you deploy your own code with something right next to it, and they all live together. So how does a service mesh combines these two concepts to actually providing a mesh network? So this is a high-level architecture of a service mesh. So there are several implementations. Istio is one of them. Linkerd is another one. MyAsh is another one. Based on traffic. So this is more or less what a service mesh looks like in general. So you have two planes, the control plane. The control plane is where the administrative services live, so where all the configuration lives, where the proxies contact the plane to get information, how they should configure themselves. And then there's the so-called data plane. And there we can see that we have an instance of a service, or all of your services, and you have the sidecar proxy. So the sidecar proxy will contact or somehow get information from this control plane, and then it will configure itself and do whatever you guys configured it to do. And then, of course, it can export traces and metrics to another system you have observability. So in theory, this is more or less how a service mesh in general works. Istio is an implementation of a service mesh. There has a lot of companies developing work on top of it. It will handle authentication, monitoring, load balancing, circuit breaking for you, and it's being handled as infrastructure as code. So it's one of the possible implementations of a service mesh that you can have that you can put on your own infrastructure. Not surprisingly, actually you can't see this very well, but you can get the idea. So this is very similar to what we had before. So here we have the control plane, and the control plane for Istio has a few services, which are called Mixer, Pilot, Galley, and Citadel. And here is the data plane where you have your own services and the proxy itself. The proxy, it's based on Envoy. And we will touch on each of them and see what their actual purpose is. So Envoy is a proxy developed in C++, and it was developed, if I'm not mistaken, by Lyft. They are using it in production. They are serving billions of requests per day, so it seems to scale very well. And all Istio is built on top of Envoy. So basically what Istio does is provide capabilities and a way for Envoy to configure itself to actually provide a lot of functionality that we are going to see in a bit. Another component is Pilot. So Pilot is what provides Envoy the capabilities for service discovery, and it will handle stuff like intelligent routing, doing stuff like A/B tests, canary rollouts. It will also handle resilience, so it will give all that configuration so that Envoy can configure itself so that it can do whatever it's configured to do. Pilot is built around loose coupling, which means that you can run on multiple environments. So Istio was built with the idea of being extensible by default. Although it has some preferred technology at this point, it was built so it can be extended to other components. Another component is Mixer. So Mixer is the component that will be responsible for enforcing access control, and all the policies that we will see in a bit will be handled by Mixer. Next component is Citadel. So Citadel will be the certificate authority and authentication component for Istio. So if you enable MTLS, so Citadel will be responsible for issuing certificates and giving them to Envoy so they can encrypt and authenticate each other in the mesh network. And last but not least, Galley is a component that the only thing that it does is validate. So when you give a configuration to Istio, it will be responsible to making sure that everything has the correct syntax and providing the other service that configuration for it to run. So let's start by seeing some of the concepts that Istio can do for us. So one of the first component things that Istio can do for us is traffic control. So we need to, in our systems, we need a way to actually manage how traffic goes into our services. So two that we are going to see here are Canary deployments and dark launches. And these are stuff that big companies like Netflix or Amazon, Facebook, Google have been using for years, but they had to develop their own systems. Some of them are open source, but Istio and other service mesh networks provide us a way with actually only providing configuration to handle that. So let's just see how that can be achieved. So the first one that we'll see, it's canaries. So I don't know if you are familiar how the name canary deployment came to be. So the basic idea was that when miners went to mines, they took a canary with them. Why? Because canaries are very sensitive to gases. So if a canary just stopped singing or just died, they knew that they had to flee the mine. So that was like a warning sign. So the idea here is more or less the same. We start to route some traffic into a new version, for example, of a service. We check our metrics, our tracing. If everything looks okay, we start to move more traffic into that system. If not, we just roll everything back and we're back to square one. So basically, this is more or less how it goes. We have our version v1. We deploy our version v1.1, and we start to port some traffic into v1 and then gradually move everything if everything looks okay, and then we'll just basically redirect no more traffic to version v1. So how can that be done in Istio? So it has two concepts: the destination rule and the virtual service. So basically here I'm just setting up the two systems. So here I have a generic recommendation system, and I'm saying that I have v1, which is recognized by labeling. So label v1 and label v2. So basically, here I just define what my services are. And at this point, I have all of my traffic going to version v1. So how do I start to route traffic? So I play with this virtual service. I start by maintaining 90% of the traffic on version v1 and version v2. And gradually, I will start moving traffic to version v2 until I have no more traffic on this one. So this can be done manually. You can integrate this with stuff like GitOps and change. This can be templating, and you can change these things. This can be automatically. Something like Flux or Argo integrates well with Istio. Flux more actually with Istio. But this is a way to actually move traffic from one point to the other. Something that you can also do, so this one is only based in traffic. Istio has some more options. Here I'm giving an example of one. So here I'm matching by headers, and I'm saying everything that comes with a header for Safari will go to version v2. Maybe I have something that's specific for Safari users on version v2, and everything else goes to version v1. So it's not only based on traffic, but you can have other criteria to actually split traffic between your systems. And this, as you can see, is just a matter of configuration. I don't have to touch anything else. Next is the concept of dark launch. So a dark launch, we can do it in a couple of ways, but the basic idea is a dark launch is that you deploy a version of your application that no one sees. Maybe you want to just give that access to a specific client, something that someone needs to see. Maybe it's a proof of concept, maybe it's a feature just for a specific client, or something a pattern that is very common is that you want to replicate all your traffic that you were receiving on your production to a new system. So maybe you want to check that everything is working okay. Maybe you want to check that performance is still good with production traffic. And actually, Istio gives you a nice way to do that, but it basically works like this. Service A needs to contact service B. We deploy our v2 of service B, and we tell Istio, so we get 100% of the traffic going to in my service and my new service. And that's done just by this. So it's a very simple configuration that you give Istio, and it will basically say, mirror every traffic that goes to version v1 to version v2, and that's handled by Istio itself. This because we have the sidecar, and all the traffic flows through the sidecar, so it makes a decision based on this configuration to just split the traffic into those things. This needs to come with some caution. So if you, for instance, if you have both services going to the same database, this could be a trouble because maybe you're updating a record, and now you have two versions of the service updating a record, and there's a whole books written about this, so how to do this properly. But Istio gives you, on the high level, the possibility of actually just splitting the traffic, and then it's up to you to see how that will be handled. So this was traffic control. There's one last concept. So you can enable Istio by default to block all traffic outside of your service mesh. It's very interesting in terms of security. So basically, Istio will not allow HTTP requests outside of your service mesh by default. So you will have to tell Istio which URLs are able to be contacted, and this is done by the service entry. Here, for an example, I'm giving just an URL and say it will be available on port 80. So the idea here is to blacklist everything and whitelist only what we want. We could do it the other way around, but in terms of security, this is any security engineer will find this much more interesting to have everything blocked and just open what it's supposed to do. Next, we have something like service resilience. So one of the things that we mentioned previously is that we don't want everything to go down if a small piece goes down. So Istio will try to provide some stuff to help you handle that. We usually do that in our own code with stuff like retries, the timeouts. We have load balancers on top on front-end services that get instances out if they're not behaving well. And Istio comes with some capabilities that will help you manage all of those things. So the first one is, of course, something very familiar to us. It's just load balancing. So you have traffic coming from the internet. You have a load balancer in front of your services, and it will spread the traffic amongst your instances. And Istio has three forms. So this is the destination rule where I can define the load balancing rule. At this point, Istio had three. I don't know if they have more at this moment. So if you don't say anything, it will be round robin. You can also specify random, and it will choose one randomly from the pool of services that you have behind. And it had a simpler form of weighted load balancing where you could define some rules and it will choose the best load balancing, the best instance to receive traffic. So this is the most common thing that you can do. Another one is timeouts. So basically, you can tell the proxy when it's routing traffic to a specific service. You just say that after 1 second, probably a second is not that much, but you can tell it. So every request that goes to service recommendation, time it out at 1 second. Another very common pattern is retries. So basically, the same thing here. I'm sending traffic to my recommendation system, and I'm saying every time it fails, wait for 2 seconds and try it 3 times. So this way, you can actually decouple this retry and timeout code from your own applications, and you can offload it to the service mesh, and that's one of the biggest selling points for this kind of stuff, and it was one of the ways that we actually sold it within the company. We started with tracing, that we'll see here in a bit, but we actually had several services built on different programming language, and we had to re-implement all of this, retries for Node.js, for Golang, whatever it is, and we actually concentrated all on the same stuff, and we could focus on writing the code for the business, and this was offloaded to elsewhere. Another interesting pattern that Istio also can handle is circuit breaking. So this comes from the electronics world. So the basic idea is that a certain number of conditions are all positive, the circuit will break. And what this means, these are usually bad stuff that we think that are bad. So if those conditions all happen, we'll just basically open the circuit, which means that no traffic will flow for the recommendation system in this example. So the idea here is that we want to give some system some slack. So maybe it's behaving well, maybe it's handling too much traffic, or maybe even one specific instance, and we wanted to leave it for a while, and then we can bring it back. And Istio gives that support. So let's see how it's done. Here, for example, I'm defining a traffic policy, so I'm telling that I'm only handling one request, and I want only one request pending. So basically, I have here a very critical system, and it only handles one request at a time, and I don't want any more only more than one request pending. So, and how do I eject? I open the circuits, so I basically here saying that if I have an error, I'll just wait for a defined amount of time, and I will eject that instance for 2 minutes. So maybe it does something heavy on the database, and I want just to leave it on its own, and I will eject 100% of the requests. And I'm doing this only for version 2. Maybe it's my new version that I'm not sure how it's behaving. And here is the same virtual service that we had before, and I'm splitting the traffic 50-50. Chaos testing, or chaos engineering. Probably most of you have heard about this, and it's a nice way to test everything that we've seen up to this point. This was mostly popularized by Netflix a few years ago. They had the concept of breaking stuff, so at least that's what people in the beginning understood it was. We just go into our systems and break stuff. They popularized that a little bit further because they had actually business people that were not fully aware of what their systems were, and they could just inject failure. So let's say 0.5% of the traffic for this service will be errors, and it could happen. But the idea of chaos testing or chaos engineering is not to inject failure, it's to actually build confidence on your system. So we have seen before stuff like circuit breaking and timeouts and retries. So how can we actually make sure that when failure happens, this will all be in effect? And that comes with chaos testing. Like I said, it's the art of breaking things on purpose, but it's not breaking the stuff, is actually making sure that they work under specific failure conditions. And Istio comes sorry, with at least 2 capabilities that they make it very easy to test this kind of stuff. So the first one is errors. So here is an example where I'm saying that every 50% of the requests that go to the recommendation service will give an error back. So that will be handled by retries or timeouts. So 50% of the requests will come back with an error, and then your timeouts will be responsible for handling how many requests it's going back. So it's very easy to do this. So you can add this, and because we are doing this, we know exactly what we are injecting, so we know exactly what we can test and see what's going on. And another one, probably even more critical, are delays. So you're contacting a system and it just doesn't answer back. Is it erroring? Is it not? It's just taking too long. And in this example, we're injecting 7 seconds of failure on top of whatever the service does. So this will at least take 7 seconds. So probably we're testing our timeouts. Maybe we have an SLA, or we have a critical system that cannot take more than 3 seconds, for example. And here we're on purpose injecting 7 seconds on half of the request. So this is a very nice and easy way to actually inject failure, in this case, on top of our systems. One interesting thing that when you go into microservices, and usually it's not a critical thing because you want to actually deploy your code and have your stuff running and making money, but at some point you'll have failure, or you're deploying a new version of a system and you want to understand what the hell is going on. This is getting too slow. Is it the database? Is it some service that's processing? It's AIO, I don't know. So we'll need observability, and that usually comes on 2 forms, either tracing or metrics. And Istio gives a lot of support. Let's not forget that now we have a proxy alongside our services, and we have a lot of stuff that's going there. Actually, all the traffic is going in and out through that proxy, so that proxy can actually get some metrics and get some traces and send it to somewhere. So first thing that we are going to see is tracing. There's a project, open source project called Open Tracing that's actually hosted by CNCF, so it's basically a standard. And it's built on the concept of a span. So a span is it has 2 components. It has an operation name. Let's, for example, think database query. It's the operation name. And then it has a start timestamp and a finish timestamp or a duration. So basically, you can have something like operation name, database query, start time X, and it lasted for 2 seconds. And a trace is it's a graph of a bunch of spans. So let's imagine, we'll see in the next slide. Let's imagine a request that comes into our service, and each service that it touches, it will produce a trace and say, this started here, it did this thing, and it took this long. And if you use something like Jaeger or Zipkin, there are a lot of options for this, but Jaeger is from Uber, I think, developed by Uber. It's also open source, and we can see this very well, but we can get an idea. So basically here is a request. So something came into the customer service, and it took all this long, and it touches all of these services, and it took this long to actually execute. So here we have an idea of when a request comes in, what's happening along our infrastructure. If you enable this 100% tracing on your system, this will have high impact, so it's not advisable to enable on 100% of requests in production. You probably want this on dev or some validation environment where you are actually being sure that everything works well, but Istio has a support for sampling. You use something around 10–20% will be more than fine for production, but because you don't want to track every single request, because this will have a high impact on your systems. Another thing that Istio comes by default is metrics. Again, the proxy, it's Envoy, it exports a lot of metrics. One integration that it has is with Prometheus. So here, for example, we're just plotting for version v2 of the recommendation system the requests that are coming, and it comes by default with this. You just need to enable it, and then you can have Prometheus scraping it from the Istio control plane and plotting that. And of course, you can plot that on Grafana or whatever the platform of your choice is, and have all of those metrics without having to deploy, to actually build metrics endpoints and all that kind of stuff. One interesting project, this one is developed by Red Hat, and it's part of Istio. So the idea here is that you have a service graph. So this system is Kiali. There are others, but this is one nice example that we tried. Basically, you have to give it access to the control plane, and it will start to actually guess for you what services are deployed and where the traffic is going. It's interesting to know because it will do the graph itself, and if something breaks, it will actually start reporting that, for example, customer V1 cannot contact Jaeger or preference system V1, and you can see that you have a problem here. And it will do this all by itself. And last but not least, we'll handle security. So it's easy to think that you are on the microservices world, and maybe you have a very small and very tiny service and everything is fine. It doesn't do anything special, but now you have a service that contacts with many others, and you can hack one and just get into a system by one small import. So Istio has some support for security, and we'll see a few things that it can do for us. So the first thing that it's fairly easy to configure is mutual TLS. So basically, you just need to define a policy and a destination rule, and it will start like magic to actually just issue certificates and give Envoy certificates so that service can authenticate and encrypt traffic among them. Of course, one of the ways, if you're using Kubernetes, to get traffic into your system is through an ingress gateway. So then this is, if you're using mutual TLS, these are the configuration files that you can actually use to actually get traffic into your system, and it is basically self-explanatory. I'm opening port 80 to receive HTTP traffic, and I'm matching if everything that comes from a / will go to customer on port 8080. And Istio will handle the mutual TLS by us. Something very interesting also is access control. So something, I don't know if anyone is working in finance, but one of the things that you have in finance is PCI compliance. And one of the things that the auditors look at is actually what services can communicate with each other. And service A is only allowed to communicate with service B, but the other way around is not permitted. Then service B can only speak to whatever that is. So in Istio, you have a way to actually put that in code. So it makes a lot easier to provide actual code for the auditors to see that everything is working as we are telling it to do. So in this example, we have a customer service, a preference service, and a recommendation service, and we only want traffic to flow this way. So this is the way that we are actually setting that stuff. So we are saying that the customer service, which is matched by labels on the label app, and the destination, sorry, and the recommendation service, and we are only allowing traffic to flow on this way. If that's not happening, just block every traffic that's going in there. And of course, we have role-based access control, where we are just saying on top of these rules that customer can contact a recommendation can contact preference, but they can only get requests into themselves, so they cannot do posts, they cannot change data. Maybe only preference can mess with the database, but the other one can't, so I can't do a post from recommendation to preference. And there's much more. We can do policy enforcement, we can do mesh expansions, here are hybrid deployments, advanced ingress rules. There's a lot of stuff that can be done here. So one of the ways that we actually started to, how we sold this to the company was with the tracing part. So the idea that we started to have dozens and dozens of services, and we needed a way to actually get information about our systems, and that's how we sold it. So one of the things that Istio and most service mesh networks have is that it's fairly easy to actually get it into the door, but you can turn things on and turn things off, so you don't have to have everything or nothing, so you can just have the service proxies alongside your services, and they're not doing nothing, traffic just flows, works like a normal proxy, and then you can start adding features. So we started with the traceability because we did some experiments actually instrumenting all of our code, and we started having a penalty performance that was very high, and it was not the idea of the business to actually handle that code, so we needed to make money, and that was not the point to actually handle the tracing. So that was one of the ideas that we sold it to the company, and then we started adding features. So we're saying, okay, so now we have 3 or 4 services in different languages. What if we handle timeouts and retries all on the service mesh and actually remove that code from the application code? And progressively, we started to introducing circuit breaking that we also wanted, but it was costly to manage. So you can gradually add features on top of this and sell it to the company like that. So thank you. Everyone, if anyone has any questions, just shoot, please.
Okay. We will have 4 questions, like 10 minutes or so. There.
First of all, thank you about your talk. It's really interesting.
Louder, please.
Just a little bit louder.
More? No?
Ah, that's good.
Yeah, thanks.
Yeah.
And my question is about one of the topics you are talking about, is case engineer. In your own opinion, when is the moment to introduce these kind of approaches?
Using a service mesh, when it's the moment?
No, case engineering.
I'm sorry, I didn't understand.
Chaos engineering.
Chase?
Like chaos engineering.
Oh, chaos engineering. Oh, yeah, sorry, sir. So, let me just push it back. It will be basically, okay, so this, you deal with chaos engineering every day, right? You deploy a system, it will fail. Someone will try to break it. So you're already using this, not only on purpose. So if you have something like Istio or something that you can inject failure and test it by itself, you can start using it right out of the gate. Of course, it's tricky to do this in production. So you're on purpose producing failure. So one of the ways that we started doing this was gradually going from dev or whatever your span of environments were, but we out of the gate started doing this in development. So let's just break stuff. At the beginning, we didn't have a service mesh, so we just broke stuff. So we went into some service and shut it down, and let's see what happens. Did the load increase or whatever it was? But as soon as you can do this comfortably, you should start doing it right out of the gate. Because it will actually build confidence, and it will actually give people say, okay, so we're in a good position, even if half our infrastructure goes down, or our database starts spinning, things will more or less go well. But I understand it's tricky to do that in production, but as long as you start building trust along the way, it's more than fine to actually use it.
Thank you very much.
Yeah.
Hello, I have a question regarding canary release. Mm-hmm. So the toggle that Istio can provide. So in my case, I had a case that I wanted to release, like I was upgrading the language from PHP like 5 to 7.
Yep.
And I wanted only certain users, so cluster of users, be redirected into a new version.
Yep.
So let's say 1%. So the way we accomplished it was thanks to like those like hash stored in cookie,
yep.
so that if I'm a user, I will be always, every single request, redirected to the same version.
Yep.
So does this tool, this Istio, provide such a...
So in this example, I'm using a header, but it supports cookies or something else. So you can match certain stuff. I'm here just showing an example of a header. It could be a header, so maybe you just want, this example, Safari users to use that new version, or a specific cookie to go into that. So this also supports that.
Okay, awesome. Thank you.
More questions?
Can you hear me? Hello?
Hey.
Okay, hi. Thank you very much for the talk. It was very interesting. My question for you is, based on your experience, do you see service meshes as like basically the next level of abstraction for like orchestrating workloads basically, or do you think that there are like use cases that won't be served well by it?
So at least in my experience, this comes with several benefits, but it's still a little bit hard to actually do this. So it's not as hard as it was 1 year ago, but it's a nice abstraction to do on top of those things. So more and more, a company is built to make money. So your business owner will not care if you're doing timeouts a certain way or retries a certain way. Just he expects everything to work. And if you offload for example, the retries and timeouts to a specific part of the infrastructure, it will be easier to actually do that. The thing is, like what Kubernetes was a couple of years ago, you have to deploy almost on every cloud provider. You have to deploy this by yourself. I think only GCP has support for Istio by default. No one else has. Amazon has, but it's their own service mesh, which I don't think it works with EKS yet. I'm not sure. So when there's a way to actually click a button and deploy this, and then you just need to supply configuration, I believe this will actually be the default standard. Actually, do you know Knative? So Knative is built on top of Istio, so it will actually will be more or less a de facto standard with Lambda functions and serverless. You will need a way to actually do this kind of stuff with the Lambda functions. So this is a nice way to actually do. So I think probably in the next year or so, this will start to be the standard.
Thank you very much.
Okay, more questions? Okay, I think that's all. Thank you very much.
Thank you, guys.
We have a present for you.
Oh, thank you.
From the organization.